In this short presentation, I will briefly present the Baltic Sea windwave hindcast system. My name is Witold Cieślikiewicz. The co-authors are Dr. Badur, Ms. Cupiał, and Mr. Wegner. We all represent the Institute of Oceanography, University of Gdańsk. Our group's interest is focused on windwave physics and modeling. The work I will be talking about is a part of the ecudo.pl project entitled Oceanographic Data and Information System. The ecudo acronym stands for the Polish version of the project title. PL, of course, indicates the Polish internet domain. Our project centers on the Baltic Sea. The main project objective is to make the Baltic Sea oceanographic data publicly accessible in a transparent and convenient way. On this slide, the project partners are listed, each responsible for different kinds of oceanographic data. I'm not going to go into too much details, as there will be a presentation in this conference fully dedicated to this project. The University of Gdańsk is responsible for providing the windwave data. The project coordinator is the Institute of Oceanology of Polish Academy of Sciences in Sopot. Why windwave data are important? What are the main applications? Here I listed most obvious applicability of windwave data. I can mention the offshore engineering, for example, offshore structure design, coastal engineering, for example, coast protection and management, marine transport, such applications like route optimization, wave action on vessels. Next, ports and harbors, their design and exploitation. There are solutions for retrieving energy from sea waves. Wind waves domain is also part of general oceanography, namely sea dynamics. For example, topics like mixing in surface layer. The state of wind wave field has an effect on sea surface friction, so plays an important role in atmosphere-ocean models. Let me also mention leisure, sport and tourism, in which, depending on kind of activity, one may also need to take waves into account. Here I would like to show some elements of wind wave modeling process. We use our implementation of the famous spectral wave model WOM. In figure on the left, a computational area is presented. The green frame shows the border of the grid covering the whole Baltic Sea. Its resolution is 4 nautical miles. We also use a chain of embedded models. Dark blue frame shows the 2 nautical miles resolution grid covering southern part of the Baltic. Purple indicates areas modeled with 1 nautical mile resolution. We also consider using even finer resolution of half nautical mile to model with a greater accuracy a region where 2 of 3 most important Polish ports are located. In the middle figure, a 2-dimensional energy spectrum is presented. It's what actually the WOM model computes in each node of the grid at each computational time step. Based on those spectra, all the basic wind wave parameters are estimated. As an example, the distribution of significant wave height over the Baltic Sea is shown on the right figure. In this contour plot, the area marked with gray shows the ice cover taken into account in our computations. This slide shows the structure of the IQDO system. We've got a central system running at the Institute of Oceanology and a number of federated systems, each related to one of the project partners, providing various kinds of oceanographic data. One of them is WindWave Data, federated system run by the University of Gdańsk. The University of Gdańsk federated system of IQDO creates metadata that are available for external users. Metadata are published in the GeoNetwork folder, and WindWave data are made available using the REST API. Both the GeoNetwork and the REST service are externally accessible based on Docker container mechanism. Our GeoNetwork federated system is connected with the central GeoNetwork system. The federated system contains also an internal database which links WindWave data with appropriate metadata. An external user downloads or browses metadata which were downloaded by the central system from the University of Gdańsk GeoNetwork. The federated University of Gdańsk system makes the data available for downloading. To download the data, for which the external user already has metadata, it is enough to submit a request to the federated system using its REST API. To conclude, I would like to emphasize a few points. Modeled WindWave data are collected in databases that will be openly shared with a wide range of users and stakeholders. This data can be used by researchers, authorities, practitioners, and the public for their work in marine sector or for tourism and leisure. The IQDO project addresses currently existing drawback of typical data system, i.e., one has to search several scattered separate IT systems or to order personalized expert analysis when needs a particular oceanographic data. We do hope, using our data system, it can be done in a transparent and much more convenient way. Thank you for watching.